Good evening, everyone. Thank you for joining this webinar. I'm Dhyanesh, Product Manager here at Grey Campus. Before we get started, a few housekeeping notes. All of your lines are muted by default, but we'll have some time in the end for questions. Please use the Q&A panel to post your questions. We see and hear a lot about artificial intelligence and machine learning technologies these days. We are aware that AI is impacting the future of virtually every industry and every human being. To be honest, there are a lot of people struggling to understand how best to take advantage of the progress in this field. In this session, we focus on solving this problem. Today, the topic is powerful use cases of artificial intelligence at work, and also how Grey Campus programs developed in collaboration with IBM can help you accelerate your opportunities in AI. It is my pleasure to introduce our esteemed speaker and course advisor of this program, Rajiv Kumar, who will be leading the session. Rajiv has 22 years of experience in the IT industry and has worked with multiple Fortune 100 clients. Rajiv has developed multiple AI-enabled solutions in various fields ranging from fashion to education. His solutions have saved millions of dollars to his clients. Without further ado, I'm going to hand it over to Rajiv now, who will take us through this presentation. Over to you, Mr. Rajiv.
All right, thank you, Danish. Am I audible?
Yes, Rajiv.
All right, thank you, Danish, for confirming. All right, everyone, good evening and good morning. Today's webinar, we are basically going to look at some of the use cases where we can apply AI at work, make it very useful for us. So just to kind of, first of all, just a quick look at the agenda. So first of all, we will understand why do we need AI? I mean, there's just tremendous amount of hype around artificial intelligence. So we will first understand where do we need it and why do we need it basically. Once we understand that, we are going to look at some of the use cases for AI and see what is involved in building artificial intelligence machines, right? And then we will also talk about what skills do you need to build AI solution. So we're going to talk about how we can, I mean, once we understand what is AI, how it can be used, then we will look at how you can, what are the skills that are needed to take up AI ML projects. And then we will also share some good reading material on AI ML. So that's the agenda at a high level. So let's get started. Let's first understand why do we really need AI. Now we've been using computers for a pretty long time, and computers do some amazing things for us. I mean, we have built all kind of code out there, and more work is getting done through computers. Now, how do they make a computer work? If you look at, let's try to understand. Let's make sure we are on the same page. Suppose my requirement is a very simple one. We want to calculate area of a rectangle. Let's say, business came to us and they said, okay, we need a program which can calculate in an area of rectangle. Right now, in this case, how we calculate area of rectangle? As we know, I mean, we probably have, read in maybe 4th or 5th grade that area of a rectangle is nothing but length multiplied by width, right? We know this one. We know the logic of building, calculating area of rectangle. Knowing the logic, and what we do, we basically prepare, sometimes we usually prepare a detailed step document. We usually call it design document in software engineering, but it will have the kind of things we want our program to do. So this will not be the actual program, rather we write down what are the steps that we need to code for, right? So depending on, again, there could be different version of, how to implement this requirement, but, it would look something like this. We get some input, and then we get the two sides, then we multiply, then we display it, right? And these are sometimes called algorithm, right? The design of your program or application is the logic that you need to code it. Right? Once you have the design ready, then what will happen? You will go ahead and code it, and then of course you deploy it to the machine. And after a few errors here and there, it starts to work. Right? This is how we do it. I mean, we get a requirement, we prepare our design document, we code it, and then deploy. Right? That's how things work. Now let's look at another requirement. Suppose we are asked to, a business comes to us, hey, we need an application which requires sales tax to be calculated. For example, we have quite a few countries, and even in India, we have this goods and sales services tax, GST. Now, a lot of us may not really understand how to calculate GST. Now, if the requirement comes that, hey, you need to build an application to calculate GST, and we don't have the logic. Now, if we don't have the logic, we cannot start coding for it. So now in this case, what will happen? Basically, because we don't have the logic, we go back to the business or maybe the finance team and ask them, hey, how do you calculate sales tax currently? What is the logic you use to calculate sales tax? And business team will help us out. They will write down the logic, and we will prepare our own design document. I mean, an algorithm. Like, hey, this is how the logic for sales tax might look like. Again, depending on how business team has described it to us. Right? So we get in this case, we are going to, in case of area of rectangle, we had the logic because we learned it in our 4th, 5th grade class. But here we did not have it, but someone else had. Like, we basically went to the business team and they explained how sales tax is calculated. And based on that, we prepared our design document. And once we have the design document, we code it. We just code the logic into a program or a bunch of programs. And we can use different languages, maybe Python, Java, C, C++, and so on, depending on what our organization prefers. And then we give it to the machine. Right? Then we give it to the machine. So just to this is how we basically make things work. Although we might have different nomenclatures for these tasks, but basically what happens is, first of all, we get the requirement, and usually the business teams are the ones giving us the requirements. Once we have the requirement, we basically try to build the logic, right? Try to build the logic, and we basically, to build the, essentially this step involves design document, right? This is where either we have the logic ourselves, as was the case with area of rectangle, or we get logic from some other team in the case of calculation of sales tax, right? Once we have the logic, we convert that logic into a program, and then we essentially give it to the machine, and we deploy it on the machine. Right? Everybody is comfortable with this approach. All of you are familiar with this approach. I hope so. If not, let me know. But this is how things usually work out. Now, let's say we have another requirement. And in this case, what do you guys see in this? You can put your response in the chat. What do you see? I know it's a little silly, but let's go along. So this, as you can see, this is, and all of us will guess this is an elephant, right? And again, we see a bunch of elephants, although it looks a little different than what we had in the previous picture, but still nonetheless an elephant. Right? Two of them, little different color. Now, what about this? How many elephants do we have in this picture? Anybody wants to take a shot at it? You can put your responses in the chat. How many elephants do you see in this picture? Anybody? All right, I guess nobody's ready to count them. Okay, but I mean, you will see that there are several elephants, and I mean, depending on how closely we are looking, we might get a response like 12, 13, 14, or more. Depending, I mean, 15, like as Harshit said, it could be 15, right? Again, but there are several elephants in the picture, right? Now thing is, we have a requirement now, just like our sales text, and so our requirement is we want to build a program which can identify elephants in a picture, or different elephants in a picture. So let's say, I mean, we have this, this is, let's try to write down what are the steps we basically will need to code. So before we can code, we need to have some logic, which we can code. So we need to prepare our design document. Now to come up with this logic, we can start, writing down, what are the things that are unique about this elephant. You can post your thoughts in the chat or in the Q&A. What are the unique features of an elephant that we use to identify elephants, different elephants? You can post your thoughts in the chat or Q&A. So our goal is to build a program to identify elephants in a picture. And so we want to write down what are the key features of elephants. Is the question clear, everybody? What are the key features? How do how do we know that this is an elephant? What are the things that we look for? What are the things are there? First of all, I think we can say that there is a trunk. Right, trunk is a major feature. Not many animals have that. Trunk, yes, a trunk is yes. Trunk is one. What else? What do we think? The tusk, these big teeth, right? I mean, we can say tusk is also a key feature of an elephant. What do we know? Anything else? Anything else? Legs, or Bhagyashree is saying legs. I mean, pillar legs. Okay, pillar-like legs. Very right. Very true. Pillar-like legs. What else? Any other thing? Eyes. What about eyes? Everybody has eyes. Anything? Is there anything unique about elephant's eyes? Arshad? Little droopy. I mean, it's kind of, it's hard to say, but yes, I mean, their eyes are a little different from us, right? Bigger eyes, right? Bigger eyes, a bit maybe bigger eyes, and ears as well. Bigger ears, right? I mean, our ears are pretty big relative to us, though, right? Bigger is bigger ears, right? Anything else? Now let's look at these features. Let's see if these features can help us come up with identify different elephants in this picture. Now trunk, this elephant definitely has a trunk. That's definitely there. This one also has it. This one also has it. This one also has it. But there's an elephant right behind this one. There's this elephant which is for whom the trunk is not really visible. Same thing about this elephant. It's hard to say whether the trunk is there or not. We humans have the imagination power, but our program, we cannot code imagination. Right? We know that there is a trunk for those elephants in the back as well, but it's not available in those. It's not visible in the picture. So we can see that with trunk, we can identify maybe 5 to 6 or maybe 7 elephants, but not 14 or 15 that we are seeing that are there in the picture, right? You see the problem, right? You see the problem. The tail is also there. Yes, tail is there. Now, how about tusk. Is tusk there for every elephant in this picture? Right? Is that tusk there for everybody? Every elephant in this picture? If you see, I mean, this elephant has a tusk, but I mean, this is a baby elephant. There's no tusk. In this case, it is visible. This is visible, but for the rest of the elephants, there's no tusk visible. There's no tusk visible, right? We can see that only if we use tusk, we can identify maybe 3 elephants, but but others we cannot identify using a feature like tusk, right? Similarly about the legs, we have pillar legs, but again, the legs may or may not even be visible. Sometimes we say we have, elephants have, we know that elephants have 4 legs also, right? But even, sometimes the legs are not even visible. It feels like as if there are 2 legs, or like for the elephants in the backside, there's no leg visible, pillar or no. Right, you see that difficulty is, we basically, as we have used 3 features: trunk, tusk, and the pillar legs. It's not visible. No, not for all. Same is the case with eyes and ears. Right, eyes may or may not be visible. Again, lot of animals and humans, I mean, have eyes. I mean, so it's we have to be very specific what kind of eyes elephant has, or the ears. Now, even bigger is a very difficult thing. We cannot code bigger in our program. We have to be very precise. What does bigger means, right? For example, this elephant definitely has this much here. This elephant has this much here, right? What does bigger mean is hard to say. And moreover, the elephant's ear may not be really visible. Same is the case with tail, right? Very, I mean, I think only in this case, the tail is visible. Otherwise, it's not even visible for any of the elephant, right? So if you see, I mean, based on this discussion, you see that it's very hard to say what is unique about elephants in the picture. We know though, we have an imagination, but it's, a lot of these things are not visible for every elephant. And without that knowledge, we cannot prepare our logic. Right? We cannot prepare our program should check for these things. Even if we write logic for these 5 items, our program will not be able to find more than 5, 6 elephants in this picture, or maybe 7. Right? It will fail. It will fail. Right? So you see the issue here is that the logic part is not very clear to us, and that is definitely needed before we can take up the coding. Unless the logic is clear, unless our design document is ready, we cannot start coding, right? Because in the design document only we say, okay, this is the logic that we need to code for, right? So the logic is not clear. So the problem is, I mean, as we saw earlier, to build a application or a program, we need to do 4 things. First of all, we should have a requirement. And in this case, we do have a requirement. I mean, the requirement is to build a program to identify elephants. So the requirement is there. But the problem is we don't have the logic. And the logic part is not very clear to us. It's not very clear. We have few things, but that can only take us so far. It cannot allow us to identify different elephants in the picture. And if you don't have the logic, how can you code that logic, right? Because our program is totally dependent on the logic that we have defined. And if our logic is not there, that means program cannot be created. And if program cannot be created, we cannot deploy it to the computer. Right? So we saw that issue that sometimes we don't have the logic to do certain things, or don't have a good logic to carry out the work, right? And when we don't have the logic, we cannot write program, for that requirement, because program requires logic. Now, our brain is using some logic, right? I mean, all of us know that, I mean, all of us could see these 14, 15, or 18 elephants, and our brain was using some good logic there. And that's what we had that. We said imagination or something. But the thing is, quite often we might be able to do things, but brain actually does not tell us what exact or logic it is using, what exact logic it is using. Right? It has the logic, but it doesn't tell us. Right? And if it doesn't tell us, we cannot code it. Right? We can code only the logic that we know. Now, given this limitation, can machine see things? Right? Given this limitation, can machine see things? So let's take a look at a program. Let's go to Google search and see if machine. Now Google is everybody able to see my screen, web browser, or no? Maybe no, I guess. Are you able to see my web browser? No. Okay, let me stop sharing and then share my entire screen. Thank you. How about now? Are you able to see? Yes? All right. Thank you for confirming. Yes. Thank you, Abdul. So let's look for elephants, elephant, I mean, and I'll go to images. Right? Google search on images, and you can see, Google, it has brought forward, images of elephants. And again, sometimes things are visible, sometimes things are very small, not really visible. All those features we talked about may or may not truly be visible, right? But it is able to identify elephants in all different poses, right? And you can see the machine. Google search is a program, essentially. It's nothing but a program running behind the scene. So it is able to identify elephant here. Now, elephant is still it has a definite shape. I mean, if we try hard, maybe we can go a little closer to building a program. Now, let's look at an object which doesn't really have a shape, like geysers, right? So geysers, okay. There's a geyser and geyser, okay. All right. So what geyser I mean is these, the steam coming out of our planet Earth, right? You would have seen something like these. Right now these geysers can take different shape. I mean, they don't have any particular shape. This is a geyser, this is also geyser, this is a geyser. And I mean, it's hard to define what exactly is a geyser. Even here, there's a geyser here, I mean, in this picture, right? So it's very, very hard, but what we see is machine is able to do this. It's able to find out, what a geyser looks like. It knows what a geyser looks like. Of course, it's geyser shares the same letters with the this hot water geyser, I guess, and it's that's confusing, but it is actually able to find different type of geysers without really having the exact shape of this object. Right? So we see that machine is actually able to find these things. And although we saw that we have a hard time writing down the program because we don't have the logic, but machine is able to do it. Machine is able to look at a picture and tell us what is there in the picture. Is it an elephant? Is it a geyser? It is able to do that. Now, how is it able to do this? Is through this field of artificial intelligence. And what is artificial intelligence? Basically, it essentially involves building these intelligent machines who can do these tasks, which usually are done by humans, right? I mean, that, for example, we humans have the power to see things around them. They have the vision. Now, what we want to do we want to build artificially intelligent machine which can have vision, right? Or machines which can understand language like us. We are speaking English right now. How can we make machine understand English or any other language, Tamil, Telugu, Marathi, German, French? Or how can machine reason like humans? Given a scenario, can it reason things? And that's at the heart of this field of artificial intelligence, where we try to build intelligent machines, which can do tasks which usually are done by humans, right? Now the question becomes, all right, so we want to have machines which have these capabilities of a vision and language understanding and all. Now, how do we build artificially intelligent machines? Right. So let's look at that. So there are different ways of building AI. For example, there's a method called finite state machines. There is another method called knowledge reasoning. But most of the progress in AI field has come from this field, another field called machine learning. And machine learning, and I mean, so machine learning is not same as AI, but the machine learning is a way to build AI, right? And within AI, within ML, there is a subset of field called deep learning, which actually has helped made us huge amount of progress in the field of artificial intelligence, right? So deep learning is the one which is mainly responsible for all the the progress that we see currently. Major progress that we see in AI currently is coming from the field of deep learning. All right, so that's how what AI basically. So as I said, is needed. In AI, we try to give capabilities to machines which are similar to us, right? And quite often, how do we identify AI use case? Is a use case where we do not know the logic on how we are doing these things. If we don't know the logic, we cannot code it. And that becomes a very useful scenario to apply AI at work. Right. So you look at your organization, your work, your teams, and what they are doing currently, and analyze what part of the work we understand the logic, what part we can do but cannot understand the logic. And if we have things where we don't have the logic, we can use we can build an AI machine using machine learning, right? So that's what we can do. Now let's try to look at few examples where we can where we can use AI. I mean, and again, the amount of use cases is tremendous. But let's look at a couple of them and see what is involved. For example, let's look at this one. We are basically we have all across the world. I mean, we have these traffic violations, like people crossing the red light or not wearing helmets and so on. And these are dangerous not just for the drivers, but even for the other drivers. I mean, other people who are in other cars. I mean, it could be it can result into fatal accidents. Now it's very hard to keep monitoring, who's making a mistake. It's a very manual, very laborious process. So what if we can? I mean, what we can do is, because this involves a power to see things. If we put a person there who keeps looking at these drivers who are making a mistake and kind of do the fine thing. That's it's very hard job. First of all, sitting down, keep straighting and not missing things. So what we want to do is we can look to automate this process, where we will have a application which will identify the vehicles which have violated, say, red light crossing, and immediately come up with a fine for those. So again, and this could be used to discipline the folks and hopefully reduce these kind of violation, which actually can save lives. right? So let's see how we can actually do this part. So what's needed for this? So first of all, I mean, we will, of course, we will need a camera to be on as soon as the red light comes on, right? We will need to install a camera. And once we have the camera, what we can do, we can take that camera feed, those pictures that are being taken by camera continuously, the video feed, we can feed it to an AI/ML model, an AI/ML model that we basically will build. Now, what this AML model can do, it will basically look at each frame in the video and tell us whether there is a car, right? Whether there's a car which is going ahead even though there's a red light, right? And if there is a car or a two-wheeler, what is the license plate number? It will identify the license plate number for that vehicle, whether it's a two-wheeler or a four-wheeler, right? And once we have the license plate number, then we can look up a database and say, hey, who's the owner of this license plate, and basically notify the owner of the fine, right? All can be done without manual intervention. And hopefully, as people get their fine, I mean, people know that they can be caught very easily. Hopefully, they will reduce or stop violating, red lights, traffic violation, right? So we basically, so now if you see in this case, there will be certain things which will be our regular programs like this one, identifying the owner is just a database search, no ML, but there will be certain ML components, right? Usually we try to build a solution, AI/ML based solution will involve both AI/ML components as well as non-AI/ML components. Now, what is needed from AI/ML perspective in this use case? So what we will need to understand a algorithm called convolutional neural networks, CNN. We will need to understand that. What else? We will need to understand a technique called object deduction. Object deduction is to identify where are things in the picture. Where are things in the picture? So we will need to learn object deduction. We will also need to learn about how do we process image. So a lot of image processing techniques will be applied so that our machine can learn better. And finally, we will learn how to deploy this ML model in production. Right? I mean, it's one way to build up, and any application we build, we will need to move it to production. Right? So these are the things that you basically will need from AI/ML perspective, and of course there are non-AI/ML work, which is like the front end, back ends, and all that will also stay. So these are the key skills that you will need from this use case perspective. How do we automate traffic violation fine here? And if some vehicle is crossing the red lights, how do we automate that process? Right? Now, let's look at another use. So this is one use case. Let's look at one more use case. Now, quite often we are bombarded with a lot of information. And I mean, not just us, but I mean, people in every industry. Now, can we basically make it easier using AI/ML? Right? That's you have too many things to take care of. So we can build a solution like text summarization. We can summarize things. Now, who can use this? Who it could be useful for? And I mean, most people in most industry can take help from this. For example, let's say we have a lot of medical professionals, doctors, and there's so much research going in medicine, and they have to keep up with all the new things that are being brought forward. Like there's just tremendous amount of information flow in the field of medicine. Now it's very, very hard to read all those different journals. I mean, it takes a lot of time. If we build a text summarizer, it can go through those journals, summarize them so that doctors can quickly glance through those and decide, hey, which one seems interesting, I want to read that. Right? So it will be, or just get a quick glimpse of what is possible. right? Rather than spending hours and hours reading through the journals, they can, in quick time, get a summary of what these different journals are talking about, right? Similarly, like for lawyers, every country keeps getting these new laws. Also, you basically in a court, you can cite older court rulings to say, okay, this is what was ruled earlier, and that's how this is a similar case. Now, lawyers need to keep up with what has happened in the courts, so they have to read a lot, right? And again, just the amount of information coming to them is just tremendous. And if we can help them summarize it, if we can summarize things for them, they can, it'll be a big benefit to them. Not just that, for all of us, all of us get so many emails. It'll be great if we can, first of all, say what is a spam, what is not a spam, right? And within what is not a spam, what is a work email, what do I need to do? Can somebody read and tell me in one sentence or few words what is needed from that email? Right? And without me reading it, can some program read it for me and tell me what is needed? Right? So again, we can use a technique like text summarization. Now, what do we need for text summarization? What kind of AML skills you need? You will need something called recurrent neural network. Also, you will need to, there is a technique called long short-term memory, LSTM for short. Also, you will need to understand something called sequence to sequence models, and attention. Again, these are heavy duty words, but we will learn about those, or we can learn about those, and build a text summarizer. We will also talk about something called word-to-vec embeddings, and we also will look at, we'll need to learn techniques for text preprocessing. Right? So different skills needed for this use case. Right? Now, we saw two use cases, one in where we are trying to give power of vision to the model, in case of, of a traffic violation use case, where our machine is going to see things, how things are going on a traffic signal. So we are giving a power of vision, right? So that field is called computer vision. And here we are trying to, in this text summarization use case, we are giving the power of, having machine understand natural language, right? Natural language, or like English, right? Again, this can be done for any language that we are interested in, right? So we have talked about two, very useful use cases. One in the case of computer vision, another in case of natural language processing. Now, how can we gain such skills? So to gain such skills, the skills of natural language processing or computer vision using machine learning and deep learning in AI, I will request Dhyanesh to take you through that, how you can gain these skills that can be used to build these wonderful AI models. Dhyanesh, over to you.
Thank you so much for your insightful session, Rajiv. We have learned a lot. Before we go ahead and discuss the questions, I request all of you to post the questions in the Q&A panel. Meanwhile, I'll quickly take you through the Grey Campus Certificate Program in Artificial Intelligence. So this is our certificate program in Artificial Intelligence. A great way to start off to leverage the AI technologies would be to learn them firsthand. That's what we feel. And the AI certificate program offered by Grey Campus is designed for enthusiasts like you and is built in collaboration with IBM. So you must be thinking there are a lot of programs in the market. Why should I take up this program from Grey Campus? I would say the most unique value that this program holds is you'll get an IBM certificate on both program and course level. All the courses, we have different kind of courses we bundle together to make the program. So what are you going to get from IBM apart from the certificates? So we also get labs, all the lab environment for data science with Jupyter, R, Scala, and few other things that are required for AI is being provided by IBM. And you'll also get some credits where you can use them on IBM Credit Clouds. And the program is designed in such a way that it covers all the topics that are required for AI. Like Rajiv was mentioning, the key topics that is required to code or use the AI at work. And the first one, like we begin with something like data science with Python, which covers the basics of data science or artificial intelligence. And then we take you through the deeper concepts like machine learning, deep learning, NLP, and computer vision. All the course modules that are chosen as part of this program have been thoroughly observed where the industry is using it. We have picked it, we have worked on it, and we have compiled it to make it this program. So if someone is taking this program, I would definitely say they are job ready for an artificial intelligence job. And one more thing, I would say in today's time, organizations are finding difficulty in recruiting the right talent in the field of AI. The major drawback is there are enough candidates who can talk about AI ML, but there are not enough who have practical knowledge. So this is where I find Gray Campus program is making a difference. So if you have seen all the courses, there are major topics like Python or working with NumPy or SciPy or anything, the key topics in every course. We have assignments for all the key topics where whatever that you learn as part of the course, you, in that topic, you'll be practicing an assignment. Or once the assessment is complete, or you'll be covering a lot of topics in a course, there will be a project at the end of every course to test all the skills that you learned throughout the course, whether through self-learning or live online training classes, or whether through the assessment that you have already done. And once you finish all the courses, there are two major capstone projects that you have to use all the skills that you learned throughout the program. In this way, you'll be working a lot with these tools, and these capstone projects, I would say these are real-time projects that you'll be coming across when you take up a job in artificial intelligence. So this is where I find Gray Campus program is making a difference. And last but not least, you'll be getting a certificate from IBM, like I told you earlier. You'll be getting a course level certificate and also a program level certificate. We know how much of this certificate has value in the market, or how much it is recognized in the industry globally. Gray Campus Data Science or Artificial Intelligence Certificate Program provides you with a unique blended learning experience at nominal amount as compared to the providers in the market. Thank you so much, guys. Over to Mr. Rajiv to discuss the question and answers.
All right.
Yeah.
Thank you, Danish. Thank you. So you can put your questions either in the Q&A and or in the chat. We can take it up now. Are any of you currently using AI/ML in your current work? All right. So Bhagyashrie's question is, more on image processing. So image processing essentially is involved in the field of computer vision. So in computer vision, in ML, basically we try to train our models using image data when we are training on computer vision. So what kind of image processing we have to do? So quite often, first of all, the images that we get, we usually get it in different sizes. So one of the very basic thing is to make sure all our images are of same size. And then what we do is usually augment or basically create a lot of images from existing images using something called image augmentation, which is basically like, for example, we might want to rotate a picture to create a new picture from existing, or shift a picture, or sharing a picture. Right? We try to do different kind of transformation on our pictures so that we can train our model with a variety in our data. So image processing, involves, quite often is image augmentation. And finally, in machine learning, it's all about numbers. So ultimately what we do, we take up that pictures, augmented pictures, and then we convert it into an array of numbers, right? And then only we give it to the machine to process, right? So that's at a high level what image processing, what is in the kind of image processing that is involved in computer vision, right? So augmentation and converting it to numbers. So those are the two key areas. All right, Bhageshri, any other question? Okay, question is there from Suresh, and the question is, do we require any programming language? So having programming language, knowledge is good, but it's not essential. As part of the program, you will be taken through Python programming class. So you will be acquiring that knowledge. So it's not needed, but if you have knowledge in any programming language, that is always a plus, right? But it's not really an essential. You will be going through a Python programming class. All right, Suresh? Thank you for the question. Thank you, Narendra.
Yeah.
Okay, question again. There's a follow-up question from Suresh. Is that how difficult it is to learn this course without programming language? I would say, I mean, for example, I mean, it's not that you need to, it's not a must. You will need to put some amount of effort to learn Python, and the Great Campus team will be there to support you through. So you can surely do this program if you're interested, but you should be willing to learn programming. The programming will be involved, so but it is not required that you have that knowledge right now. You will be gaining that skill during the course. You can certainly do this course without a background in programming. All right, Suresh, let me know if all right. Thank you, Suresh. Thank you. Bhagyashri's question is, are we using Python or in this case, we have for data science, we have two programs. We have data science with Python and we have data science with R. So two different courses are there. So we have a choice there. In case of AI ML, it's mainly done through Python language. And so AI ML is mainly Python, but data science can be done with Python or R. All right. Any other question? I know we said bye, but if you have any question, do let us know. I'll be more than happy to share. All right. If no other questions, thank you very much, folks. Thank you very much. Stay safe. And please do let us know if you have any other question. You can always drop a note to the support team, and we'll be more than happy to come back to you with an answer. All right. Thank you, folks. Thank you very much.
Thank you, Rajiv. Thank you so much, everyone, for attending this webinar. If you still have any more questions, please reach us at support@greycampus.com. I hope you all stay safe. Thank you.